Okay, so our topic for today is 8086 microprocessor. So of course, we'll start with Intel 8086 features. So Intel 8086 is the enhanced version of Intel 8085. You're done with the Intel 8085, right? That's week 7. Okay, so basically it's just the enhanced version and it was designed by Intel in 1976. Can you mute your everyone? Can you mute your speakers? Your microphone? Can you mute? Kindly mute your microphone. Okay. So it's an 8086, a 40-pin IC. It also is a 16-bit processor. What do you mean by 16-bit processor? Anyone? Okay, when we say 16-bit processor, what do you mean? It means that it can handle a different values from, it can process numbers up to 65,535 in a single operation, okay? That's how many numbers it can process. Its operating voltage is 5 volts. Its operating frequency is 5 megahertz. Actually, we have different megahertz for different versions of Intel 8086. The total memory addressing capacity is 1 megabyte. And we have 16-bit data bus and 20-bit 20-bit address bus. It has a 14 16-bit registers, and of course has a higher output, a higher throughput. So let's go to Intel 886. This is the actual image of Intel 886. So it looks like a simple IC, right? But with 40 pins. You can see here the model. This is D8086 with the maker, Intel, and manufacture date, 1978. And this is the pin configuration. So we have here the AD0 until AD15 and A16 until A19. Now, difference between 8085 and 8086. It is an 8-bit microprocessor. That's 8085, while 8086 is a 16-bit microprocessor. Now, it has the 8085 has a 16-bit address line, while 8086 has a 20-bit address line. .8085 has 8-bit data bus, while 8086 has 16-bit data bus. And the memory capacity of 8085 is only 64 kilobyte, while the memory capacity of 8086 is 1 megabyte. The clock speed of this processor, or the 8085, is only 3 megahertz, while the clock speed of 8086 varies between 5, 8, and 10 megahertz. The actual versions are 8086, 8086-1, and 8086-2. Now it has 5 flags for the 8085, while the 8086 has 9 flags. So what do you mean by flags? Anyone? Anyone? What do you mean by flags? Okay, flags are modified kind of registers that record the condition of a microprocessor's calculation. Okay? Next, we have the 8085 microprocessor does not support memory segmentation, while 8086 microprocessor supports memory segmentation. When we say segmentation, it's the process in which the main memory of the computer is divided into different segments, and each segment has its own base address. So basically, it is used to enhance the speed of the execution of the computer system so that the processor is able to fetch and execute the data from the memory easily and fast. So here, 8086 is faster because of the memory segmentation. If you have any question now, you can ask. Next, it does not support pipelining, the 8085. While the 8086, it supports pipelining. What do you mean by pipelining? What is pipelining? Class. Okay, pipelining is the process of fetching the next instruction when the present instruction is being executed or executed. Next, 8085 is accumulator-based processor, while the 8086 it is a general purpose registers-based processor. So basically the difference between accumulator-based and a general purpose register, accumulator base, the code is smaller and it runs slower, while the register base, the code is larger and runs faster. Okay. Next, it has no minimum or maximum mode for 8085. While the 8086, it has minimum and maximum modes. Later on, we'll know what maximum and minimum modes are. Then in 8085, only one processor is used. So it's related to this one. It has no minimum or maximum mode because it's only using one processor. But for 8086, more than one processor is used. An additional external processor can also be employed. So it means later on, we'll explain the minimum and maximum modes. 8085, it contains less number of transistors compared to 8086. Microprocessor, it contains 6,500 transistors only. While 8086, it contains about 29,000 in size. The cost of 8085 is very low, and the cost of 8086 is high. Okay, can you understand? Okay. Next, we have two different operating modes. As I've mentioned before or earlier, we have the minimum mode and we have the maximum mode. When we say minimum mode, we only use one processor. In maximum mode, we use multi-processor. Okay, that's the operating modes of 8086. Unlike 8085, it has only one processor. Okay? Now, we have the functional units of 8086. 8086 contains two independent functional units, a bus interface unit or the BIU, and an execution unit or EU. So this is the block diagram. What did you notice in the block diagram? What did you notice in the block diagram? Yes? Anyone? When you want to talk, you can unmute, huh? Anyone? Okay, sige, I'll explain. In the block diagram, we can see that it is divided into two. The first one is the BIU, this one, and the second one is the EU. Okay? So what is BIU or the bus interface unit? It fetches the instructions from the memory. Okay, then write the data to a memory and also read data from the port and also write data from the port. Basically, it just fetches the data from the memory and also from the input-output port. Okay, then it will store it here and then save it again, write again to the memory. Then let's go to the EU or the execution unit. The functions of execution units are, it tells the BIU where to fetch the instructions or data from. It decodes the instructions or data, and it executes the instructions or data. Okay? So the difference basically, this one stores or fetch the data from the memory. Then it will send it to the EU for the execution. Okay? After execution, it will send it back to the BIU, and then the BIU will write it to the memory, the instructions. Okay, functional parts of 8086 microprocessor. We have the instructions queue or the instruction queue. Here is the instruction queue. What did you notice? What did you notice in the instruction queue? You can unmute and answer, huh? What did you notice in the instruction queue? Anyone? Anyone? What did you notice? Diba we have here rectangles? How many?
6.
6. Very good. Because instruction queue is used to prefetch and store at the maximum of 6 bytes of instruction code from the memory. You get the data here and you store it here up to 6. Okay? Next, we have the segment registers. So where's the segment registers? These are the segment registers. Can you see this? Okay. We have the ES, CS, SS, DS, and IP. What are those? So let's just give a brief definition of ES. ES is the extra segment register. It is an additional data segment which is used by the string to hold the extra destination data. Now we have the CS, or the code segment register. It is used for addressing a memory location in the code segment of the memory where the executable program is stored. This one is the SS, okay? Or what we call the stack segment register. It is used to compute the address of the stack location to be accessed. Then we have also the DS, this one. Can you see it? DS, data segment register. It consists of data used by the program and is accessed in the data segment by an offset address or the content of other register that holds the offset address. Then we have next, the last is the IP or the instruction pointer. It is a 16-bit register used to hold the address of the next instruction to be executed. Okay? Next, instruction pointer, of course, we have I discussed this. It is a 16-bit register used to hold the address of the next instruction to be executed. Next, we have the execution unit. You already know this, diba? What is execution unit? What is the function of execution unit? Anyone? This from here, oh, diba? I explained it. This is the execution unit. So what is execution unit? Anyone? Class. Sige, what is execution unit? Based on the word, execution unit.
It performs operation and calculation.
Okay, good. And others?
Receive instruction from the queue.
Okay. So again, execution unit tells BIU where to fetch the instruction or data from. It decodes the instructions and it executes the instruction. Okay? Always remember that, huh? Decode the instructions, then execute the instructions. That's it. Now let's go to general purpose. Again, let's go back to the block diagram. Okay, so where is the general purpose? This one. Okay? So we're done, diba? This one is the queue. This one is the, what is this? This one, what is this one again? This part. What is this? Yeah, it's written. Instruction queue. Okay? And then this part is the segment register. Now, this part is what we call the general purpose register. Okay? Remember that, ha? Instruction queue. It stores up to 6 bytes of data. These are the, what are this one?
Segment register.
Very good, the segment register. And this is the
General purpose.
very good. General purpose register. That's good. Okay. Again, instruction queue, segment register, general purpose register. So we'll start with the SP. What is SP? It is the stack pointer. So the function, it points at the current top value of the stack. It acts as an offset to the stack segment or the SS, di ba? So it's an offset to, SP is the offset of the SS, this one. From here to here. Then we have the BP. What's the BP? Base pointer. Okay? It stores the base address of the memory. Then the offset, it also acts an offset for the SS, this one, or the stack segment. Then we have the SI, or the source index register, this one. It is used in the pointer addressing of data as a source in some string related operation. It's offset relative to data segment, this one, DS, SI to DS. Then let's go to DI. DI, the destination index register. It is used in the pointer addressing of data and as a destination in more string related operation. It's offset relative to extra segments. So DI to extra segment. Okay? Understand? Okay, well, let's go back. So what is this? What is this side?
Instruction queue.
Okay, good. This side?
Stack register.
What? What is this side? This one? It's the segment register. And this? With the red? Very good. The general purpose. So that's the main part. We also have here the, what is this one?
Logic unit.
Arithmetic logic.
Okay, very good. So what is the function of arithmetic logic unit? Based on the word, arithmetic. Arithmetic and logic unit. What is arithmetic and logic unit, or ALU? Okay, it performs what?
Arithmetic and logic operation.
Very good. That's it. ALU performs the math and logical operations on command by the EU. So that's the function. Okay, let's go. So let's go to index register. So index registers are used as general purpose registers. So also almost the same as general purpose register. Then ALU. Again, what is ALU?
Arithmetic logic unit.
And the function?
Those all are arithmetic and logical operation.
Very good. Arithmetic and logic unit, or ALU, performs math and logical operations on command by the execution unit. Then last is the flag register. We have the flag register. What is a flag register? It determines the current state of the processor. Okay? Next, we have the interrupts. Interrupt is a process of creating temporary halt during the program execution and allows peripheral devices to access the microprocessor. So this is the interrupts. We have two types, the hardware interrupt and the software interrupt. And under hardware interrupts, we have the maskable interrupt and we have the non-maskable interrupt. Okay? So what is a hardware interrupt? Hardware interrupt is caused by any peripheral device by sending a signal through a specified pin to the microprocessor. So we have two types, the maskable interrupt and the non-maskable interrupt. But first, what is a, wait. Okay. So then we have two, the maskable interrupt and the non-maskable interrupt. Okay, the maskable interrupt, when this interrupt is activated, these actions take place. Number one, complete the current instruction that is in the progress. Then it pushes the flag register values on the stack. Then it pushes the CS or the code segment value and the IP instruction pointer value of return address on to the stack. So the IP is loaded from the contents of the word location 00008H, while the CS is loaded from the contents of the next word location 0000AH. So of course, the interrupt flag and trap flag are reset to 0. Now, we also have the, that's the non-maskable. Then we have the maskable interrupt or the INTR. It's a maskable interrupt because the microprocessor will be interrupted only if interrupts are enabled using set interrupt flag instruction. It should not be enabled using clear interrupt flag instructions. So basically, these are all the interrupts. Okay, do you understand? And then that's it.